Good.
All right. All right, well, we're going to get started here. Welcome to the live chat, Porous Implants. Our special guests today are Dr. Sheryl Lewin, who does porous implant ear reconstruction surgery, and Aaron Noble, the CEO of Poriferous, who makes the SuPor implants. We are very excited to have these two special guests today to teach us all about porous implants. And so we're going to go ahead and get started, but I did want to show everybody our cute little flyer here. It says, since everyone's ears are unique, shouldn't we make an ear by replicating a child's natural ear? So this is what we're talking about today. And I just have to share with you, I'm actually Dr. Sheryl Lewin's Microtia patient liaison, and I do have a son with 2 porous implants because he was born with bilateral microtia and atresia. And so I'm at like this level of techie talk. And yesterday we did a run through, and I got surgeon here, engineer here, and they're talking up here. And I'm like, we gotta bring the techie language down. So we're gonna have a great time today. Super knowledgeable. It's gonna be super fun. And Dr. Lewin, do you want to formally introduce Mr. Noble?
I certainly do. Hello, everyone. Thank you for joining us. I'm really excited about today's talk because we get a lot of patients asking me more specific questions about these implants and how I came to use these implants, and particularly lately about the 3D implant. And so honestly, what I do today in the operating room is really, I credit a partnership, between myself and Aaron, who is the president of Poriferous, because we started maybe first talking in 2014. And at that point, I was using Medpor, the traditional 2-piece implants. And honestly, just a series of wonderful conversations of, 2 minds trying to think about how to bring this to the next level led to a really incredible relationship over the last 5 years, to the point where, I honestly don't think I could be doing these 3D ears without this partnership of the back and forth and such. So Aaron will tell you a little bit about his background and training, but what I want to talk a little bit about has to sort of do with what I didn't expect in a relationship with someone who's manufacturing something for my patients, which is really, sort of the big heart. It goes with the big brain, those 2 that he has, that has really made my ability to, on a moment's notice, pick up my phone, get Aaron, even if he's somewhere around the world, to help answer something or help a patient with something. And he's very generously offered and has donated all of the implants for our Earicles patients. And we have a couple 3D Earicles patients coming up. And so again, those would not be possible without Aaron. So sort of that more unique part of the relationship is what's the magic to me. And now I'll let Aaron, there was one other thing I was gonna talk about, Tiffany said, which was just a brief overview of our process, sort of our design process. So once I see your child in the office and we do our 3D scan and we get, an almost identical image, 3-dimensional image of the child's ear, I then do some, tweaking, for lack of a better word, just adjustments and modifications to try to get the ear implant to become what I want it to become. Meaning we have to make changes based on age and based on the skull, a lot of it based on the skull that the ear is going to sit upon. And so there's a lot of back and forth with that software aspect. And once we finalize that and approve it, they are able to deliver, Poriferous, which is the company, will deliver a sterile 3D SuPor implant to me within a couple weeks. And they do all their magic that you'll learn about on their end of an incredibly efficient way to make these implants and make them, essentially affordable enough that we can use this as a daily treatment, weekly treatment for us, taking care of these kids with microtia. So with that little bit of a background, I'll hand it off to Aaron to tell you a little bit more about his expertise.
Well, thank you so much, Sheryl. Um, when I founded Poriferous, the company that makes surgical implants, before that time, I was the senior product engineer for Medpor, over working with surgeons to help innovate and come up with new technologies. And during that time, we did have a lot of input of new ways of producing products and making things. But and it was all about working with surgeons directly. My position as the senior product engineer was to work with surgeons like yourself and to make their product, the designs that meet their needs for their patients. So I started Poriferous in 2012 and spent 2 years developing solutions that surgeons requested. And these original problems were things that I had gotten in the past, just difficulties with using the material, that it was difficult to carve or hard, or that it was difficult to pass a suture through. So in 2012, I spent 2 years developing the solution to those problems. And once I had accomplished it, I submitted the formal application to the FDA to review our work and obtained market clearance in 2014. So in 2000, so we currently supply our implants and services worldwide. And our products include over 250 catalog items. So these are items that a surgeon can just order, like a chin or a cheek implant or a jaw implant, but also implants that are made specifically for the patient, for that exact patient, in order to produce symmetry. And we do that all in our facility here in Newnan, Georgia. The factory was designed to make implants for surgeons. So our whole process of bringing all of the things, all of the steps into one facility was based on that goal of streamlining the process and eliminating that difficulty of getting these designs done and making these advancements. Our professional team at Poriferous is producing what I believe to be the highest quality implant in the world. So by having all of these processes in-house, we control everything from raw material, packaging, even sterilization is controlled in our one facility. And that gives us sort of an unprecedented overlook of each and every critical function of our device. So everything is under our one roof. Some often ask the question as far as what is the difference between Medpor and SuPor? Well, in accordance to the FDA cleared SuPor to market because it was found to be equivalent in physically, as far as its mechanical function, as well as its clinical performance. But the benefits of SuPor is realized in the OR by the surgeon. It helps them to make these, to actually work with the material and make it easier to perform the task at hand. And that is really about the fine details, accomplishing fine details and being able to carve and manipulate the material. And Sheryl, I think you might have realized some of that even early on, as far as when you carve the material and suture the material, that it just takes away a frustration that you're not fighting anymore, and you can focus on those fine details of the design. So what is polyethylene and what's it used for? Polyethylene is synthetic plastic. It's one of the best accepted polymers in the body. The material is so well accepted in the body that it has become the gold standard by which all other polymer implants are measured against. So the USP, the USP standard, references polyethylene for biocompatibility of all the other implant materials out there. So we use the standard. The material, it was first created in 1898 and has been used as an implant material since the 1940s. So they've been using this to replicate and replace other types of tissue with polyethylene. What is porous polyethylene? So I had mentioned just a moment ago, as far as polyethylene, being developed and used as an implant material in the 40s, but porous polyethylene is made up of particles that have been heated and bonded and then cooled down to form a shape. A good example of that process is like a bag of ice and how it melts and then refreezes together. in order to form structures with spaces in between the ice cubes. So after heating and cooling the polyethylene particles, we accomplish a finished implant shape that has those holes and openings. And that allows the body to grow into it, much like a plant would grow into soil. It can integrate and grow down into that space, into the spaces of the particles. The development of porous polyethylene began around 1970s, and it was first commercially cleared for use in 1985 as far as porous polyethylene. So we have 1940s being used for implantation of polyethylene, and then we jump forward to the 70s for porous polyethylene development, and then 1985 for commercial approved use in the body. Since then, over 1 million implants have been used worldwide in all areas of the head. How long, another question people will commonly ask is, how long will the product last? How long will my implant last? Well, we know that polyethylene has been in the body and for over 80 years because they started using it initially. Porous polyethylene has been used for over 35 years. And we estimate that SuPor will last the lifetime of the patient, but it's the actual true time that passes that will tell. But all indications and clinical articles point to that conclusion, that it is a permanent, non-resorbing implant that will last your lifetime. So that's kind of my overview for the SuPor. If there's any additional questions, or Sheryl, that you'd like to ask?
Can I just, do you have some of those implants behind you of some of the other products you use?
Yeah. So if you see here, we have like a jaw implant for recreating the jaw angle here. Here's an example of a chin. And these can be done in all kinds of designs. I had worked with a surgeon that wanted this to be split in 2 parts and joined together like a Lego, so it was easier to put into place. So you can see how it fits onto the face. We also produce like cheek implants, so this would augment the cheek. And of course, our ear implants with the 2-piece ear implant that I have here, as well as the 1-piece design.
You know, Aaron, I have a question for you. Just, I think one of the things that parents commonly are concerned about, well, a couple of things that they're concerned about when they're talking to me, and the concept of putting a foreign implant into their child. One of them is understanding the concept of rejection, which is a term very commonly used for, you know, Medpor or porous implants, you know, get rejected by the body. And you and I understand, you know, the kind of medical meaning of rejection and how that's not an appropriate use of that word. But maybe you can talk a little bit about that from the implant standpoint, and I can talk a little bit about, after you're done, what I think is the reason people say that word. Okay.
Well, when you think of the term rejection, that's the body's wanting to, it's not accepting of something and trying to move it out or get rid of it. And that's typically a biological response. There isn't a biologic component with porous polyethylene. So rejection, and when it's related to porous polyethylene, really isn't a very accurate word. If it was to become, you know, had some other type of thing happen to it, like tissue breakdown or infection, then it could become, it would need to be removed. But that's not a rejection of the device. That is another biologic that's, you know, seeding an infection. So it's a completely different thing.
Exactly. So it's not to say that there aren't problems or issues with any type of implant or even with cartilage for that matter. In fact, like the very early cartilage surgeons, like in the 50s, would use a mother's rib cage to try to create a child's ear. And that is a true rejection, because the child sees mom, although half of their genetics, it's not close enough without immunosuppression or such, for the body to understand and accept it as its own. So you can reject your mother's cartilage, and that would cause a destruction of that ear potentially. So we don't really do that anymore. But when it comes to this porous polyethylene that doesn't have any actual biology or living component or cells that you could reject, it's not an accurate term. It's just very commonly used. And what my feeling is it's used for exposure. And exposure just means a hole where you can see visibly this implant. I think in a week or so, or 2 weeks, Tiffany, we're having a talk just on the risks of porous implant ear reconstruction. And so we'll go into more involvement of those specific risks, but exposures is not a rejection, and it's not a problem with the implant. Almost never can the implant be blamed for an exposure. It's something to do with the tissue that's placed on top of the implant. And it's often that tissue is like not strong enough or thick enough. You get a little weak spot or an injury, and then maybe that can become a wound or an exposure. And we'll deal with that, as I said, later. But I think that helps people. The other thing is, if you can explain, so you and I both believe, I mean, one of the reasons we work well together is our core beliefs about how to make an ear jive very well. We agree on a lot of like basic premises, one of which is the rigidity of these implants is needed to get the best aesthetic. And I wonder if you can talk a little bit about why we cannot make, a bendy ear either out of this or even other materials. Why is that problematic? And why do you and I both believe that as much as it's not ideal having a hard ear, it makes for a very nice looking ear?
Well, the biggest thing comes down to the contracture of the skin and tissue that surrounds the implant. So the implant simply has to be strong enough in structure to maintain that shape. Otherwise, the body is going to progressively try to turn it into a round ball. It's going to go to the simplest form and continue to contract upon it. So if you were to put something in there that would add a level of like a hinge or a level of bending, the tissue would always be trying to move it around, and you would never have a stable, aesthetically pleasing result at this time.
Right. Although I think you and I talk about this not infrequently, what we could come up with, but so that's sort of related to the next concept that is a hard one to explain, which is how much of what you and I do is 3D scanned versus 3D printed versus traditionally manufactured. If you could sort of explain, we're using new technology and very established technology, and we're combining them. And that's led us to push the envelope to what we believe is a new level. Maybe you can talk about why we require this mix instead of just printing out, an ear.
Well, the reason that we don't just go to a new technology like printing is because we're dealing with devices that are intended to last the lifetime of the patient. And we need to have the historic steps of progressive adjustments and enhancing of designs. To jump to a brand new technology would really be almost reckless in its act. So what Poriferous has done is to leverage new technology, software systems, 3D scanning, rapid prototyping technology, including 3D printing, with traditional methods of manufacturing. So we've never changed what's the geeky term is considered a technological characteristic. So that's how a device becomes from its start all the way until the surgeon uses it in the OR. That process has never changed. It is exactly the same as it has been since 1985. And that's one of the things that the FDA, when they do the review of all of our studies and documents, they ensure that that process has stayed intact, that we're not introducing any new potential risk, any new potential methods that could in the future show up as a problem. And we haven't done that at all.
Yeah, I think that's, it's been critical for me. You know, we've been wanting to make these 3D ears for a long time. The idea is not novel. I mean, if you could do it in a cost-effective way, a decade ago, we would have wanted to do that. It just, technology hadn't caught up to, you know, a scanner that was affordable and a methodology that was affordable and something that was scalable, meaning I don't want to only offer it to, you know, a couple patients. I want to offer it to all my patients, or essentially all my patients if I can. So I think that when the scanner for me became usable on a child in a matter of a minute to capture this image, that was game changer. Because I remember the rep for the scanner, you know, sales reps, and this is the latest, greatest, best thing, you've got to get it. But I'd kind of been disappointed in the past. So I didn't have like the highest expectations, and it was a very expensive machine, very expensive. So he comes, and in 35 seconds or so, he scanned one of my staff's ears. And in another 3 minutes or so, he showed me her ear in every possible way. And I was blown away, because all of a sudden this kid doesn't need anesthesia or a CAT scan, or it doesn't cost anything. You know, there's the cost of, you know, Cove getting this scanner, the surgery center getting the scanner, so we have the equipment. But beyond that, you know, there's no charge to the patient for getting that information. And then, you know, you're the one who taught me how to refine the information and turn it into something real. But to my knowledge, the secret sauce of your company has been that whatever kind of linear process you apply to making these ears, you've been doing it with manufacturing in your lifetime career. I mean, you've manufactured parts to golf carts and, you know, all kinds of, I remember, interesting things. And that process of going from the A to B, you have a way to do it that is very cost effective and quick. And so what has kind of been, I think, other companies' hurdles is they haven't figured out how to do that in their own systems. And that's, of course, your trade secret to Poriferous, is whatever that secret sauce is. But I appreciate the secret sauce because it helps a lot of my kiddos out. So
yeah, that's great.
I have a couple of questions, if you don't mind me interjecting. One question sent in was, will the implant grow?
Good question. And that is also common if you're operating on a 4-year-old or a 10-year-old or a 50-year-old. You know, how do you know what size to make the ear? The scan captures the ear at that point in time. But what's interesting about ears, and the only thing comparable is your eyeballs. Do you ever notice when a baby is born, or when you look at a puppy, they have such cute, huge eyes and huge ears? And that's legitimately because they are something or on the order, don't quote me, 70-75% of adult size, like when you're born, some crazy high number. That number could be wrong, but I just remember it being very high, as opposed to other parts of your body, your nose, or, you know, your arm. And so when you're 4, let's say 3 or 4, you're already 85% grown. Again, don't quote me on those numbers. I always forget them off by a year or 2, but I think, you know, you're 80 to 85 at the 3 to 4 range, and you're about 90% by 7 years old. So what we do is we calculate, you know, because there's been so many people that have studied ear anatomy over time, we calculate how much bigger is your ear going to get. But you don't just go quite like that. You have to make adjustments for, there's a flap on this implant, and then there's skin on top of that, and those have a thickness that make your ear bigger. So you have to modify the implant to adjust for those little differences. So the implant itself doesn't ever change. So whether I'm putting this implant at any age for any given patient, same patient at 4 or 10 or 50, that patient's going to get the ear that their adult size ear would be. And then the other ear catches up.
Great. I have another question here. This is from, apologize if I say your name wrong, Ujjwal from India. What is the life of the porous implants? And I think we kind of have covered that, but also does it require touch-ups or anything in the years ahead? So
more and more I'm finding, short of a patient with like known anatomy issues, this last year or so, we're finding that most patients don't need revision, can get one surgery, or if they need a revision, it's like a pretty small surgery on, typically for me, the earlobe that may need a revision. So those would be done, you know, that one surgery or the second little small surgery would be done pretty close together, 6 months apart, let's say. But in terms of once that's healed, there should not be any other reason to have surgery short of a rare complication. So those would be, you know, what we're talking about, you know, maybe a Zoom you want to see is the risks one, but like a fracture, something that I've seen in the 2-piece implants, but have never seen once I switched over to 1-piece implants. So since 2017, I've been exclusively using 1-piece and we haven't had fractures, but I have had fractures of my own patients from earlier and fractures of other surgeons' patients come to me to get the new technology to avoid that. So hopefully that's gone. And the other one would be, you could still get an injury to your ear that results in an exposure or a hole or a burn or, you know, some very unfortunate accident. And if that can't be treated with just medication, then that would be the only reason I could see you needing to have a revision.
Great. Another question from Jorge. It sounds like maybe you can just kind of touch briefly on, you know, when the implant, you know, is in the ear, like, you know, with the TPF flap placed over it, just kind of explain kind of how the implants, you know, actually works and thrives.
So I've learned over the past couple years with the, you know, my evolution in the design of the implants I use, the last couple years have changed dramatically. And I've seen some crazy things with that change in my design. And a lot of it has to do with how the base is now designed. And it sits on this surface and it is nothing like the old 2-piece Medpors. And once I figured out how this base worked, that integration, which I always thought was the flap integrating on top of the implant, now it's actually as much integrating from the bottom as it is from the top. And so I've abandoned using permanent suture to hold that implant in place, which is what I would have done in the past with the 2-piece implants. I use what we call an absorbable suture. So it sticks around for a little while and then it goes away. So that I want the ears I make, you know, my ear moves a little, goes up and down a little bit. That's normal, that's natural. And so if the implant's sticking to that fascia on the bottom and then wrapped with the fascia above, it's doing exactly what this ear does, because it's being held in that same place but can move a little bit. So the tissue grows in so kind of impressively, and these 3D implants are now so thin, strong but thin. If you cut them in half and broke open that implant that had been in the body even for 3 months of time, the actual implant bleeds. Tiffany's told me that my video of that was too graphic and I'm not allowed to show it to you people, but I do have the proof for anybody interested that these implants, I mean, you wipe away the implant and blood is coming from the inside, and it's like sort of very obvious proof that the tissue does grow in.
We do have a lot of great videos on our YouTube channel. They have been edited for grossness. So, but they are, you know, many people are interested in that, not me. Anyways, I have another question. Maybe Erin, can you explain, like somebody's interested in like like, how do you make sure it's like sanitized between facilities? If you ship back to Dr. Lewin's, like, how do you make sure everything is, going into the OR properly?
Very good question. So firstly is, of course, processing everything in our facility. So we have clean rooms that are under positive pressure that make sure that the air inside is clean. And then there's progressions of pressure in different areas, different zones that are all about, near sanitary processing, almost to the sterile condition. And then without transit to another sterilization company, we move it within our same facility, in that air-conditioned space, into our sterilization chamber, where it's rendered what's called terminally sterile, or there's no biological life remaining. That comes in a double peel pouch package configuration that has a 5-year shelf life of expiration of it. And within the packaging that surrounds that protects it as it goes through transit, it's been tested for like simulated shipping and for vibrations over time in trucks and different humidity and temperature ranges. So all of the studies were done to show that it can make it to its purpose, it can serve its purpose, and be delivered sterile to the surgeon. So that's how we go about doing it.
It even actually continues, because once it gets to the OR, it's unpacked outside the OR, but the box is brought into the OR, and that room itself has a special laminar airflow that keeps the air quality in that operating room, extremely clean as well. And implants are only stored in that one room. And then further, in our practice today, we're ordering these implants, 1 to 2 months before surgery. So it's not like it could have been sitting on the shelf for a year. I mean, technically it could for 5 years, but we're ordering these patient-specific implants. So, they're really just made for you and only you, and then they're used.
Great. Dr. Lewin, coming up on Thursday, you have another live chat for hemifacial families. Do you want to explain maybe why your new porous implant design, just briefly to give a teaser, because we want everybody to tune in next, kind of what you like that's new with the new porous implant?
Honestly, I could sum it up in one word. I mean, game changer.
I think that's 2. I'm just kidding.
One, but you could be right.
I don't know.
But it is literally taken what is an exceptionally challenging case, still challenging, but it's given me like the tool to be able to provide a result that in no way could I provide a similar result a year and a half ago, honestly. So that's why I call it a game changer. It's, once I'm still learning, I still feel like I learn every day I'm in the OR, honestly. I don't think there'll ever be the day before I retire, I don't think I'll be saying, yeah, they're easy for me. They're not easy for me ever. But the challenge I was struggling with the older style implants, these overcome that. And I think that's been just a huge, probably the biggest boost in what I can do in the OR since I started.
How many, just out of curiosity, with your 3D Lewin Ear implant by SuPor, what would you say is your percentage of 3D versus non-3D? Maybe not include like bilateral one piece. Like, what are your one pieces versus your two pieces?
I mean, I think this year, I don't think I'm doing a 2-piece again, if I'm honest. The only reason I've had to do a 2-piece is the 1 pieces are only available at my operating room, but essentially everybody comes to our operating room, and so I'm not turning back. No way. Very, very pleased. And there is very few unilaterals that are not getting 3Ds in my practice today. And the bilaterals get 3Ds, but like an idealized 3D. But from a person, like the original design before modifying it was actually a patient sibling, as a matter of fact, who had a beautiful ear.
Nice. Does anybody have any other questions? I'm just trying to look here. I mean, I think you guys covered a lot. I do want to throw it out there just because, you know, with this new technology and, well, I shouldn't say new technology, but, you know, everybody still kind of calls it the Medpor technique. And we need to encourage people that that's old language. You're not cool if you call it that. It's really the Porous Implant Ear Reconstruction technique, or PEER. Medpor is a brand, SuPor is a brand. So, you know, we need to kind of help, you know, if you're in groups and different things like that, we want to try and, you know, help encourage that language, because it's confusing, you know, to a lot of these families, especially families who have new babies, because they're not, you know, trying to learn what's going on. So that's my little request for all of you. But anyways, I would, you know, like to thank our special guests. I hope you all found it very informative. I know I sure did, and I hope you continue to tune into live chats going forward. This is recorded, so if you found it extremely fascinating like I did, you can watch it again. We will have it on our website. But, you know, the other thing too is, you know, if you come to one of our EarClose conferences in the future, Poriferous and SuPor, they are one of our big sponsors, and we're always greatly appreciative of them coming. But, you know, for me, I do plan the EarClose conferences. Like, you can just tell with Dr. Lewin and Aaron, you know, their love for these patients, and you will see them at these conferences, like hugging kids, taking pictures. Like Aaron will have, you know, a kid on his lap, you know, one of the patients, you know, like holding up his implant with his ear with Aaron. It's just, you know, it's pretty unique for this. You know, you guys have a unique relationship with, you know, surgeon, manufacturer, you know, it's pretty unique, but that's also why you guys can get stuff done like that. You know, if you need a change or anything, that is pretty cool. So, let's see. I love this. Thanks, Jean. I hope you can post this so other people considering surgery can geek out on the details. Yeah. You know what? And they didn't even like really geek down, man. They kept it at our level. So maybe we'll have like part 2, like the fancy talk up here, right?
Well, I confess, I'm a doctor and an anesthesiologist and an innovator, so I've been wanting to pester Dr. Lewin. Now I know you, Aaron, so I can pester you about how we can expand this so there can be more of these kind of centers around the country. I'm going to be your high maintenance patient, but for a good way.
Thank you. I do have a quick question from Susanna from Slovenia. How long it takes to do a 3D ear? So I'm not sure if that means process it or like actually make it with Aaron, or like in the operating room.
So the processing part, Aaron can speak to.
Yep. So from the time that we receive the data until the design is done is usually, we've gotten it down to hours. So we've really refined it. And then the manufacturing time itself is we ship it out terminally sterile within no greater than 8 business days, which is an unprecedented speed when it comes to a sterile device being shipped as a medical implant.
And then if they're referring to the length of the surgery, you know, an average surgery is probably 8 to 10 hours of the surgical time. And then there's, you know, pre-surgery anesthesia time at the beginning and waking up at the end. And then you're in the surgery center anywhere from 30 minutes to an hour after surgery. And then most patients go home by an hour. And yeah, that's it. Outpatient.
Christine had asked, can you tell us when the LA conference will be rescheduled? It is rescheduled next year. What'd you say? Stay tuned. We're still signing on the dotted line, but basically the same weekend, same place, same everything. And we're super excited, but stay tuned to our website and social media. Quick question. How is the scarring and the color of the skin grafts in dark skinned patients?
Very good question. So there are cultural or ethnic differences in skin color and healing, and even genetically within families. It's not totally true, but in some darker skinned ethnicities, their dermis just creates thicker scar, and so the scars don't necessarily heal as well. I sometimes say, like, you know, a Caucasian skin tends to scar and heal quite well, but as evidenced, we don't age so well. Okay, where our dermis isn't, like, for whatever reason, quite as strong necessarily. But like, I have a lot of patients from Asia, and they really can form aggressive scar like I have not seen on other patients quickly, 1 to 2 weeks, something we really don't see. And that we have a way to deal with it because we can anticipate it. But on the flip side, you know, they don't age at all. Like, they have the most gorgeous skin. So there's some quality there that I don't understand, that does cross those boundaries. But we've sort of come up with a scar management and a pretty aggressive post-op relationship with photos and such, and tweaking things here and there to get these ears to heal as nice as possible. But yeah, it is varying between patients.
Another quick question from Susanna. How long must we stay in California from first visit until we can come home? And Susanna, I think you have possibly joined some of our other ones, but a lot of these, you might want to look at our live chat travel tips and caring for your post-op ear. We have a lot of great live chats that do kind of go into some of these in detail, but Dr. Lewin, I'll let you answer that quick question.
So I like to see you at 1 week and 2 weeks after surgery. So you get 2 visits, and your trip time is about 2.5 weeks. If you live very Western United States, we often let you go home after 1 week and you can come back for a day. But if you're really farther away than that, we just think it's safer really to have people here for that entire time. And I think it just makes parents feel better, to be honest. And it certainly makes me feel better to, like, see the ear at that point, because if you've made it through that 2-week time point, the reason, I mean, other people I know can let people go home a lot earlier, but I want to be the one to look at every single kid's ear every single time. And nobody back home can be my eyes for me, really. And if I know you don't have any sign of an infection or a rash or a problem, you know, I feel very good letting you go home. But yeah, I'm still kind of, ask Maribel, like, still
our nurse.
Control freakish.
She is a control freak. She is a control freak, but it works into all of our, as a parent, our advantages. So, you know, love that fact. Deborah from Spain, is it always necessary for a second surgery? We live in Spain, and a second travel could be difficult.
I usually can tell from so I will have a Skype consult or a phone consult with every patient if they're interested in surgery. And when I review with you your child's anatomy on that phone call, I usually can have an inkling whether it's going to be 1 or 2. And it's really dictated by the child's anatomy or the adult's anatomy, for that matter. Certain things I kind of always say too: severe hemifacials, sometimes moderate hemifacial patients, depending on where the ear is, redos of failed cartilage or failed Medpors. Those always get told 2 surgeries. And if we get super lucky and we don't do it, great. But I would warn everybody, those higher level of technically complex surgeries, I like to have that second. And a kid who's never had a surgery and kind of a very classic grade 3 microtia, that's usually a one and done, usually.
Another question from Deborah. I'm sorry if I misunderstand your question, but Aaron, you kind of touched on this earlier, but maybe we need to, like, make it a little bit more clear. Like, are these ears forever?
Like I had mentioned before, polyethylene's been used for now over 80 years in the body. But porous polyethylene is around 35 years. But it's clinically considered permanent and life lasting. There's no revision or changes that's needed to, you know, it doesn't resorb or go away. So they are intended to be lifelong.
One of the things I feel like if I was a parent and I didn't really understand about these implants or the surgery, you know, it is a complicated surgery. One of the things I feel like is an important thing to understand is, irrespective of whatever implant that you're going to use for this, meaning whatever brand or whatever style or whatever, if there were to become a latest, greatest, much better option, what is lasting a lifetime is the tissue that we put on top. So that flap and that skin is your child's. It forever is your child's. And for lack of a better way to say it, it's reusable tissue. And I have a what I call a scarless way to swap out an implant, which is what, for instance, if there is a patient that has a fracture, we have a way without any new scars, go through the back and take out that old implant, put in the new implant, and it's that tissue just takes on the shape of the new implant. So we have had people that have swapped out two-piece implants, even without a fracture, quite honestly, that where the position just isn't symmetric. And we've done a three-piece implant and just swapped it out, and it's that reusable flap makes it not a simple thing. I wouldn't go that far, but certainly a doable and safe thing.
Dr. Lewin, could you briefly just tell them which part of the body the skin graft is taken?
So the skin on the front of the ear, it's critical that the color matches ears as close as possible. So any skin around the little ear that doesn't have hair will be used on the front, okay? And the earlobe will be used as an earlobe, because that's kind of the little remnant of children with microtia almost always have a little earlobe. And however, that's not enough for all the detail now. The 3D implants require, I think I calculated about almost 7 inches square of skin, you know, I mean, not 7, yeah, 7 square inches of skin. So I still use a little bit from behind the unaffected ear. There's always excess behind your ear. And so that usually covers a portion of the front. And then the back is covered for most patients, unless they're males that have a history of hair growth on their abdomens, I shall say. Most patients use tummy skin for the back of the ear. Certain males that may have more hair growth, we use the arm, the upper inner arm, like right here.
Great. Well, I do think that wraps up our questions, and we are almost out of our hour. So I would like to thank everybody for joining us today. Hopefully you guys all follow Dr. Lewin on Facebook. And if you're not part of her private Facebook group, that is groups, facebook.com/groups/Lewin Ear. I'll put that in the chat. That is a great way for post-op and pre-op families to connect and ask the real questions. I would also encourage you to follow Poriferous on Facebook, and you can follow Mr. Noble around the world, because every other day he's in Dubai or China or Egypt or India. I can't keep track of him. He's you know, pretty fancy like that. So anyways, we hope you join us, and we will send out a survey, and I hope you take part of that. We're trying to continue these live chats based on your feedback and what you're interested in learning about, especially during these safer at home times. So stay safe, stay healthy, everybody, and we hope that you join us on Thursday for the hemifacial microsomia, if that interests you. Otherwise, we have the peer risk coming up, as well as genetics. So tune in. All right. Thank you. Goodbye.
Bye. Bye.